In the next few lessons, we're going to be looking at optical imaging devices. Now, the first device we're going to look at is the simplest form of optical imager, and that is called a pinhole. And we're going to look at the old-fashioned pinhole camera. Now, at the moment, we've just got a black box. Now, pinhole cameras were painted black on the inside, just like all cameras, in order to stop light, stray light, reflecting around on the inside of the camera and ruining the image. But at the moment this box is pretty useless, so we've got to make a hole to allow the light to enter the camera. Let's do that. Okay, so we put a hole here. You might be surprised to learn that you can actually make it or form an image without using a lens, but you can. What you've got to ensure is that this hole isn't very big. It's got to be a very small hole indeed. Now you can watch a video in the practical demos section which shows you how to make your own pinhole camera or pinhole viewer, and it may well be worth having a go at doing this. First of all, let's look at what happens to the light from the object. We're using this tree as the object, and we'll take light from the top of the tree. That light is going to come through the hole, and it's directed to the back of the camera. Now, in a camera, this is where you're going to put the camera film. Obviously, in modern digital cameras don't use camera films, but they use something similar, which is called a CCD array. And then light from the bottom of the tree comes through the pinhole in that way. As long as this hole isn't very big, then we're going to form an image. Now let's have a look. What will the image look like? First of all, we notice that because we're forming the image on a screen, then it's a real image, and you'll also notice that it's upside down, and this is called an inverted image. Now, the only problem with these types of camera is that because the hole is very small, then not much light gets in through the hole, and as a result the image can be quite dull. In order to make a brighter image, you need to increase the size of the hole to allow more light through. But there's a problem when you do that. Let's have a look and see what happens. Let's make the hole bigger. So we're making the hole bigger, we're allowing more light into the camera, but the problem now is you'll see that the light from the top of the tree can come down here, it can come down this path, it can come down through this path. So the problem is, where is the top of the tree? Well, it's spread over this area. So the good news about making the hole bigger is you get more light in, you get a brighter image, but the bad news is that the image is all messed up, it's blurred and absolutely no use at all. So what are we going to do about that? Well, we're going to use a device called a lens. Okay, so we position the lens at the front of the pinhole camera. Now, we're going to look at lenses in the next lesson, but basically a lens is designed to collect light that comes from a single point in an object, such as the top of this tree, and focus that light onto a single point on a screen or a camera film, for example. So the light from the top of the tree is collected by the lens, right, and then focused to a single point on what we call the image plane. That's to say, the plane where the image forms. Likewise, we'll change colour for light from the bottom of the tree, from the bottom of the object. Let's just use red light, for example, so that you can distinguish between the two. Okay, that light goes straight through, that's going through the centre of the lens. Alright, and the light that's coming up here to the top of the lens will be directed towards the same point on the screen, and likewise here. Okay, so by introducing a lens, we can increase the size of the hole of the camera, and therefore collect more light, so we get a brighter image, but we also get a nice clear focused image. Now what I'd like to point out here, you can't use any old lens, you must use a lens which has exactly the right focal length, and the focal length of the lens should correspond to the length of the box. That's to say the distance from the front of the box to the back of the box where you've positioned your camera film, for example. All right, so we call this length the focal length of the lens. Again, we'll look at this in the next lesson. There, so this distance here from the lens to the focus is called the focal length, and in this particular case for this pinhole camera I've chosen a lens whose focal length exactly corresponds to the length of the box, so that the image forms on the back of the box where the camera film will be positioned.